Quick update, my channel has been very quiet because I've been extremely busy, but big changes have been going on behind the scenes. Simon has joined as the head editor, so the videos will look very different from now on. The plan is to start out with a series on golden age of flight, roughly 50s to the 80s, and therefore please let me know in the comments what kind of aviation videos you'd like to see on this channel. I will stay away from speculative air crash investigation and focus on the positive aviation side. Therefore, high quality production, unique angles, made for true aviation enthusiasts. Looking forward to your feedback, and now enjoy the video. Your Captain Joe. In 1966, Frank Kolk, chief engineer of American Airlines, wanted a 250-seat wide-body domestic airliner. He was worried the in-development 747 would be hard to fill and therefore be uneconomic for domestic US routes. At the same time, the 737 being developed had too few seats for the airline's needs. Therefore, along with the 747 and aircraft like the DC-10, together with the Airbus A300, which was to come onto the market later in the 70s, the wide-body airliner concept was adopted. However, the TriStar very much played its part in this wide-body revolution. But back to the 747. Kolk reputedly said to the then CEO of American Airlines, "It's just too damn big for our route network." He originally wanted a twin-engine jet, but at the time the FAA's 60-minute rule, dating back to an era of piston-powered flight, meant twin-engine airliners could not fly for more than 60 minutes from an airport for safety reasons in the event of an engine failure and the need to divert. Therefore, the tri-jet concept got around this with the 3-engine L-1011, able to fly on 2 engines in an engine-out emergencies. But the TriStar was well ahead of its time, a technological aviation marvel, and loved by passengers and crew alike. Kolk had heard of the big new fan engines which he had on his wish list when going to Lockheed, and as we'll see, this is a major part of the TriStar story. But TWA, one of the early adopters of the TriStar, were just taking delivery of 747s, which they too considered too large and uneconomic for domestic routes, and didn't like the twin-jet idea for similar safety reasons, particularly as some of their routes took them over the Rocky Mountains. In fact, the L-1011 launch customer turned out to be Eastern Airlines when American ordered DC-10s instead. Because of being released a year earlier and being cheaper, but with Eastern Airlines having an 1,800-mile route overseas from New York to Puerto Rico, they too wanted to avoid these safety issues. And all these factors were a trigger for the TriStar project. And additionally, the extra engine solved the problem of doubling the payload of existing jet airliners on the market for short to medium routes. Rolls-Royce designed the RB211 turbofan as the only engine option for the TriStar, which was one of the first high bypass engines for commercial airliners. So called because most of the thrust is developed by the fan outside the area of the core of the engine. At the time, the £1,075 million orders of the RB211s for the TriStar was the largest ever in British aviation history, and in fact for any British industry. Also, the RB211 was the first 3-spool jet engine used on an airliner. Essentially, instead of 2 turbines connecting their respective compressor stages by shafts, there was now 3 with the aft turbine connecting the fan at the front. with the effect of more efficiency by a greater rise of pressure per stage, as well with the separate low pressure and high pressure sections of the engine. But because of the independence of the spools, the spinning front shaft ran slower to their airflow to suck in more air, translating to less noise on approach and in the cabin. Therefore, some airports even removed night curfews for the TriStar, where they kept them in place for other aircraft types. The RB211 was so good, it was the forerunner of the current Rolls-Royce Trent series of engines, and as such the TriStar project set the scene for 3-spool engines being the norm nowadays. The fan blades of the RB211 originally used a Rolls-Royce designed carbon composite material called high-fill, but when carrying out bird strike testing, the weak resin plastic could not take the impact at the thin blade leading edges. Therefore, Rolls-Royce reverted to titanium, and unfortunately the engine weight advantage over competing engines was lost. The famous TriStar's S-Duct was a 7 feet wide, 30 feet long circular duct between the intake of the central tail engine to the engine mounted lower down at the end of the duct. Having the engine along the longitudinal axis of the aircraft allowed for better balance and a shorter fin and rudder. Therefore, this was unlike the DC-10, which had a drag penalty in placing its straight-through third engine high on its tailplane, which also made access and servicing more difficult. But being called straight-through meant there was no ducting common to the designs like the TriStar or even the Boeing 727, which used an S-Duct too. In fact, Lockheed's own wind tunnel tests actually showed a drag penalty of between 2 and 4% of these straight-through designs, and why the S-Duct on the TriStar was adopted. Enclosing the engine in the duct had the effect of making it quieter as well, and that's why Eastern Airlines dubbed the aircraft the Whisperliner due to such low noise emissions, which was on top of the RB211's already quiet character. Instead of riveting many parts, another key feature of the TriStar was using a British resin material called Redux, developed at Duxford, to bond metal-to-metal parts, which were then baked in large-scale autoclaves at their Palmdale, California plant. Such a process has been used on earlier designed de Havilland aircraft. But for a publicity stunt, one of Lockheed's stenographers was photographed next to a car being held up by a 1-inch square of bonded aluminium using this resin. Lockheed's rationale for bonding metals was born out of their own tests, in that 8,000 loading cycles were required to cause cracking in bonded parts, contrasting only 3,000 cycles in some riveted parts. The L-1011 was also way ahead of its time by a number of its flight systems. It was the first wide-body aircraft certified by the FAA with a fully automated Category 3 Bravo Autoland system, meaning the pilot could use it to land in near zero visibility conditions with a minimum of 150 feet visibility along the runway surface and no need for a decision height. The original 747-100 entering service 2 years prior used a Category 3 Alpha Autoland system, necessitating a decision height requirement and longer runway visual range. But the TriStar also had an advanced automated flight control system for its time, and the first digital autopilot utilizing partially automatic fly-by-wire technology for pitch control. Notably, the TriStar used an all-moving tailplane to control pitch, such that moving the control yoke moved the whole of the horizontal tailplane and the elevator at the trailing edge for pitch trim deflection. Another well-reputed feature was the Lockheed's direct lift control system, which reduced pilot workloads during landing by automatically employing spoilers, making it easier for the pilots to stay on the glide slope without changing pitch. Now, this system, which was used in manual and automatic landing approaches, comprised lowering or raising wing spoilers on the descent, which were coupled with the pilot's pitch inputs, and the system worked with the flaps down 30 degrees or more. But the effect was directly on wing lift, much like a flat, stable approach a glider takes, using wing box air brakes to control a smooth rate of descent rather than pitching, which is only used to control speed in a glider on approach. 3 Eastern airline captains who first flew the L-1011 were impressed with the Autoland feature and also commented how visibility is excellent, for the TriStar had huge windows in the cockpit, which was one of the most spacious cockpits in the business, a reoccurring sentiment for pilots who flew the TriStar, in fact. But the aircraft also had optional air stairs with extending handrails fitted to allow entry and exit at airports lacking passenger handling equipment. It was also the first wide-body aircraft to use a ram air turbine, or RAT, to provide electrical power in the event of engine failure, basically a wind-turning propeller connected to a generator. Depending on configuration, the TriStar was a 250 to 400 seat aircraft, which gave it much flexibility. But essentially, if the airlines went for the standard ideal interior layout, they'd get 4 double seat set rows, which according to Lockheed made it possible that couples would have no middleman next to them and passengers were only 1 seat from an aisle. Seat pitches of 28 inches are not unusual on budget airlines nowadays, but with the almost 20 feet wide fuselage, a room-high cabin ceiling, and twin aisles, plus economy seat pitches of 34 to 36 inches, the TriStar had a spacey reputation amongst its passengers. Cabin doors were even recessed into the upper sides of the fuselage, and referring to the below-deck galley as a kitchen in promo materials, at odds with the modern economic ideals of using underfloor space for cargo nowadays, the kitchen had no less than 2 lifts to take food and personnel up and down. With the preponderance now of single-deck twin-engine passenger aircraft, such features were a relic of Golden Age aviation design, where aircraft were seemingly conceptualized around being flying rooms with individual functionality. Much like a hotel experience with a hidden kitchen keeps the hustle and commotion of food preparation away from customers, so did this arrangement on the TriStar. Much more a sight of spectacle was the food arriving on carts and a sense of mystique and anticipation around the whole onboard dining experience. But as part of how Lockheed envisioned the TriStar and undertaking a food service test in a mock-up fuselage at their Palmdale factory, get this: filet mignon was on the menu for economy class passengers. This was truly a sign of this classic aviation age. The whole event was filmed and to see if 250 passengers could easily be served in a 90-minute flight. Lockheed even had options for an underfloor lounge. Okay, maybe with a sea of brown and orange hues a la your grandma's old living room, but a quirky mark of this golden age of flight nonetheless. What too of a full coat closet with hangers in first and economy class cabins situated inside passenger door spaces and other areas of the aircraft, like between the seats, or even stations for passengers to decant water. And as standard, 2 toilets at the front of the cabin and a row of 5 at the back under the S-Duct, unlike the common arrangement now with everyone waiting at a single toilet location. For all its marvels, the L-1011 TriStar project sadly did not break even. It was outpaced to market by the technologically inferior McDonnell Douglas DC-10 because of delays in Rolls-Royce developing the RB211 through cost overruns and this engine manufacturer being bailed out by the British government. Eventually, production ceased in 1983, not helped by Airbus' more efficient first offering, a twin-jet wide-body which entered service in the mid-70s, the all-too-famous A300, which really took the wind out of the TriStar's sails. So whilst the TriStar was Lockheed's last foray into commercial airliners, for all the things it's given us, it has an affectionate place in the hearts of pilots and flyers alike, and it is for this it will be truly remembered. Viva TriStar!
Hey, when I'm in Europe, I'm happy. Right now I'm flying TWA over Pittsburgh, and I'm still happy, because the Trans-World Service give me the test of Europe, flying in the USA. Thank you, baby. Lasagna al forno, bolognese, just like a Euro. Bordeaux wine, just like a Euro. Fantastic desserts, just like a Euro. Sinful that Zabolione, and the romantic foreign films, just like a Euro. Scusi, ask your travel agent to get you on a TWA. Trans-World Service, making me so homesick. Mamma!